for the module champion prize also at the stake. Asha, without the module champion also, who would like to explain? Even if you open the mouth, I will consider you. Deepika opened the mouth. Okay. No, seriously, anybody who would like to take a stab? Arpan, you go ahead. Nobody else is feeling like.
So it is.
Yeah, okay, sorry, go ahead.
I think like I just read before the break. I think like PCA is somewhere it is reducing the variables and is giving the other.
Okay.
It's like for example the noise reduction.
Hmm. Right. Yep, absolutely. What else?
Uh, uh, yeah, I was.
Okay. Hmm. Okay. Fair enough.
Dimension reduction.
Hmm.
So, for example, like it's mainly used to reduce the dimension. If we are having multiple features like 30 plus features or 40 plus features, visualizing is very hard. So we use this PCA to reduce the number of features without losing any information. It will not lose any information. It will just reduce the dimension. So to reduce the dimension, it use it will use where variance is more. So if there is two key concepts present here to do that, one is eigenvector and eigenvalue. So eigenvalue represents like the variance, most of the variance, and eigenvector is a direction. It is a vector which it is a direction like where most of the variance of the data comes, and that is PCA1. And if we add PCA2, it will be orthogonal to 90 degree of that PCA1. So now the main use is to like to for visualizing the data, and if we are having almost many features, we cannot visualizing is very much hard.
Hmm.
Now another thing is like how to calculate this PCA. So if we are having X and Y feature, X and Y feature, two features are there. And, first of all, this is a unsupervised learning. There is no label. So if we are having X and Y, now we need to calculate, first we need to calculate the covariance matrix. And for the on the covariance matrix, we need to calculate eigenvector and eigenvalue. And for which vector, for which eigenvector, eigenvalue is more, that we consider as a PC1, means that vector having the direction of the vector where variance are coming. And we need to multiply the feature vector with that eigenvector to get the PCA1. And that earlier we are having two feature X and Y. Now we are having one feature. We are using PCA component as a one. So we are reducing the dimension. Where it use mainly is I have created one POC on that. While like image duplicate or same image or not. So if we create one image first, every image is having its own matrix. So if we apply PCA and if we see there is no if two image there is no variance between two images, means the image are same. So to check that also we can use the PCA. Image is same or not. Like that.
Yeah, good. Sure. Hmm?
So whenever we have any data where we don't have variables for its supervised, for that matter, we try to use it to simplify the complex data and get into a smaller format, so that at least we are able to analyze it much better. So we want to remove the noise. That
and visualize the high dimensional 2D or 3D data. That's in simple what PCA is all about. But to do that, we follow different steps. First of all, we take the labels out, then we remove the noise, then we improve the performance, and then we try to visualize it.
Great. But besides the visualization, what are the main areas?
But again, when you say main areas, what do you mean to say that?
Like, what is the main usage? Where do we use it?
So we use it when we need to find that what exactly our model will be coming up, the result will be coming out as. Whether let's say there are too many data of the similar type, so can we remove the or let's say something which is remove the components which are very near to each other, and can we transform the data, use the right labels so that let's say something which is mentioned as true and false, can we bring it into numbers? So that's why we standardize and then try to find out the actual and get a reading of it.
Another advantage is like if we are having too many features, computation is very much slow when we train the model. If you use PC and reduce the features, computation will be faster.
Faster.
Model will train faster, right?
Okay. Awesome. All good points. So I'm not able to somehow share on the Teams. It's just stuck. Not sure why. My voice is there, no? On the Teams. So I'll just. So these are the people who are in contention for the module champion. Everybody else either did not attend all classes, or I think that was the main thing. I think this is the filter, right? So if you have high hopes, then you can tame it down now. Only these people will be considered for the module champions. And you're still in contention. Anybody who attended and whose name is not there, like attended all the sessions and name is not there for some reasons. That's it, right? Okay, so I'll just like send a high level note to you, Abhi, if you can share with everybody on the PCA. Okay, so with that background, let's go ahead and start it, right? So PCA, as a lot of you are pointing out correctly, is an unsupervised learning algorithm. This is not requiring the label, and this generally falls in your sorry, too big. This falls in the space of feature engineering. So even before you do any model, you look into your features, and features are what? Your X. So what do you do with the X's to make them more suitable for the further modeling, further processing, or this could be also a product by itself, right? And as we've discussed, this is an unsupervised learning algorithm, right? So it does not require Y. There is very little role for Y in this. And the main thing that we will be talking about today is for reducing the dimensions. And what do you mean by dimension? Dimensions are nothing but your X's, right? So this is another name for your features. So when you have too many features, or where you have multi-collinearity, or where you have a lot of redundant things built in, you can use PCA for reducing the number of your features, right? That's one of the main thing. It also helps you address the noise issues, the like outliers, and some of the things where they use this as a product by itself. So we'll be talking about the dimension reduction application today, and it helps you address the curse of dimensionality. What is the curse of dimensionality? As your, huh? Go ahead. Yeah. So as your dimensions grow, complexity will grow, and then you will have higher and higher expectation of more number of columns as well. Sorry, I was writing it right. Rows. You must have a lot more data to really do justice with understanding all the x's, right? So as your x's grow, your expectation or the model's expectation on the number of observations you're providing for the training also grows, right? And sometimes you may not have that much data, right? Let's say I have a data where I have 2000 x's, or basically the columns in a data frame, and only 1000 rows observations, right? Can I capture all the nuances of the complexity in the data with the 1000 rows? Probably not, because I have 2000 variables by itself, right? And only 1000 observations. So I'm not just having enough data. So that's where the curse of dimensionality comes in, and you can reduce that by following this. It follows the matrix operation. I will not go in the math because the linear algebra will cover some of that. So there's a particular matrix method called the singular value decomposition that is used for computing the components out of that. But I'll just give you a high level idea of what exactly it does, right? So for example, what it says is that you have these x's, and all of them, if I include, they capture 100% of your information. We're not saying that they're 100% explaining your why. I'm saying 100% of the information that you're passing on in your models are being captured by your entire data. So what PCS is, okay, I can help you. I can create what we call as a components like PC1, PC2, PC3, and all of that in a way that I will help you reduce the number of features, and you'll have to pay a small price for it, right? So for example, this was capturing 100% of your explaining power. I can give you 3 components which will help you retain 80% of your explaining power, right? And I can go, let's say, from original 15 features to 3 components now. So you can see what is happening. So you're doing a very drastic reduction in the number of features, but you're not losing much explaining power. So it's a trade-off. There's no free lunch, right? So if you're reducing the number of components or features, there will be some drop in the information value, but that drop will not be proportionate to it, right? And what we do is either we use the components or we can use the factors which are coming in from the components for doing the further processing, right? What is the rule that we use as a default one? We use the 80%. So we should have the number of components, and that will become clear when we do the walkthrough of the code. So number of components which explain at least 80% of the variance, right? So that's what basically this boils down to. So the number of components should be explaining 80% of my original variance, and then we are good, right? The other rule people use is that eigenvalue. Eigenvalue is nothing but how much explaining power each component is going to retain, right? So for example, component 1, hypothetically speaking, if it has an eigenvalue of 3.7, so what it means is it is packing the explaining power worth of 3.7 variables in it, right? So that's the significance of the eigenvalue. So you're packing all the variables into the components. Each component is taking the knowledge of the original data, and it is saying how much explaining I have, right? So you can follow this rule also. Then there is a scree method, something similar to what we've done earlier on. So let's just do a walkthrough of this, and then I'll come back to and explain, right? So you can see this data is wine data. Everybody was able to run the code. All good, right? So what does this wine data has? It has the classes, which is, I think, the quality of the wine is what basically we are looking at. And then it has these other things like alcohol content of the wine, malic acid, and other characteristics of the wine, right? So it's like a wine tasting. So people were given the wine and they tasted and they rated very good, good, or whatever the categories are. And then these are the components of the wine. So we want to do a PC on this. So let's understand what the data has really. So you can see it has 3 classes and these all things. PCA, remember, does not happen on Y. So the very first thing that we have to do is to drop it. Not needed. Y is not needed for the doing the PCA, right? So only X's are required. So that's what we're going to do. Is this clear so far? Steps, right? And one of the things very, very important in the PCA is must do scaling or normalization. Before you move on for any PCA activity, you must scale your X's, right? Because it's a distance metric in the matrix operations and everything. So you must scale your data. So let's go ahead and do the scaling. So you can see we've done the scaling on this and we got all my things, right? Till here, everybody's good. Very typical modeling workflow, nothing different. Let me see if I can zoom in a little bit so you can see it better. Is it better now? And I will close this so you can see bigger, right? The very next thing we are doing is we are importing sklearn decomposition. From sklearn.decomposition, we are importing the PCA, right? And what we're doing, PCA, we are doing, basically you can do the same thing as the logistic regression, right? And linear regression. So we're doing PCA in one step. I'm doing fit. What are we fitting on? Scaled features, right? So this is nothing but your scaled features, right? That's what we are fitting it on. I don't know why this has become suddenly thicker. Okay. Doesn't help. Okay, never mind. So after we've done the PCA, we have this object called PCA, right? And if I just do PCA dot explained variance ratio, right? Explained variance ratio, that means, first of all, the number of components in the PCA, the number of components will be always equal to the number of features when the PCA is run without the number of components. So it will always form that many number of components as you have the number of features. So how many features did we have there, if anybody remembers? Look into your Jupyter notebook and tell me how many features, not the variable, the dependent variable, but the features. 14 or 13? So label is the 14th one you're saying? Okay, let's just check whether that is correct or not. 13. Okay, so let's just go with 13. So let's see how many components we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did we miss out something? I think, so there's one here, 13. So you see there is 13 components matching with the 13 features. Then where is the variable reduction happening? There's no variable reduction. So we started with the 13 features and we got the 13 components. We will do a subset of this, right? And how are we going to do the subset? Is by looking at this number over here. The English interpretation is that this variable explains 36% of the original data. One component alone is packing the power of the 36% of the original data. How much is the power in the second component? 19%, right? Similarly, the third component is 11%, right? And so on and so forth. So it's always that way. So the first component will pack the most explaining power. second component will have the second less, and third component, and so on and so forth, right? So we'll go till how many components? Where we explain the 80%, right? So, and if I did the math correctly, that came out to be 5 components. So instead of looking at all the ones, we can say 1, 2, 3, 4, and 5 components. If I just go with the 5 components, I will match my criteria of 80% explaining power. This is being ensured if I just capture the 5 components. So how much is the variable reduction? Variable reduction has happened. Variable reduction has happened from 13 to 5, right? 13 to 5, and explaining power has gone down by 20%. So you can see this is a good trade-off. So I'm, reducing the number of variables to almost half, or more than half, actually around 60%, while I'm just losing 20% of the explaining power lost, right? So that's the gain of the PCA, right? So let's carry on. So you can see this is like PCA explained variance. This is nothing but your eigenvalues, right? So remember the criteria also was that eigenvalue should be more than 1. So ideally I should not have these, but I'm having these because I also want to ensure 80% of the explaining power. That's why I have it, right? So what does the eigenvalue mean? That this component itself can explain 4.7 variables worth of information, right? So this variable, this component itself is packing the power of the 4.7 variables that you had in your original data. Similarly, 2.49, 1.44, and so on and so forth, right? Oh, features, yeah, correct. That's right. No, they're all different. So I'll talk about that part. Yeah. So, but what is a component actually really? And that's quite funny. A lot of people get completely tripped on this one. A component is nothing but combination of features. So PC1, for example, yeah. Where? Here.
Yeah, sequence of features will be same.
Hmm.
I mean, this is the value.
That's right. That's right.
whatever we have common.
That's right.
So you can come down. So when we are saying that, okay, we want 80% is the target, and we are able to pick up the value based on that. What was the degree? Yeah. So now, the question was same, like whatever is it, component. So which features are going in which component?
I will explain that. Yeah, you'll see that coming in.
Okay. That was my question.
Yeah, I'll show you. But let's look into what the components are first of all, right? So component PC1 is nothing but alpha 1, x1, alpha 2, x2, till alpha 13, x13, assuming that we had 13 variables. And these are your alpha values for the component 1. These are nothing but your alpha values, right? Similarly, let's say PC2. PC2 is nothing but beta 1, x1, beta 2, x2, beta 3, x3, till beta 13, x13. And what are these beta 1? Who can tell me where exactly do you think this might be? Yeah. So these are nothing but your things, right? That's all basically it does, right? But what happens is, and I don't know whether we have done that earlier or not. I think we're doing it over here. So let's see. I don't have the histogram, I mean the heat map. So if you look into this heat map, I'm jumping a little bit. No, I mean, this is not capturing that one at all, right? So this is something you can do. Or maybe there it's in my notebook. I don't have that handy right now. If you do a heat map on your original x1, x2, x3 till x13, not even heat map, if you just do a correlation, you will find that x1 might be correlated to x13, right? Or I mean, it's like proportional related to x13 and so on and so forth. X2 might be related to x5, right? And so on and so forth, right? They might be related. However, when you do the PCAs and when you do the PCA correlation of PCA1 to PC2, what is the value you're going to get? 0. They're completely orthogonal. They're not related to each other at all. That's the beauty of this. I mean, that even though you're looking at all the underlying features to create the linear combination of the components, but because of the matrix computation which is happening underneath, PC1 has nothing to do with the PC2. Similarly, PC2 has 0 correlation with PC3 and PC1. 0 correlation. So all of them are completely unrelated to each other. So if you wanted to do the mother of all multi-collinearity effects in your linear regression, you will just simply do a principal component. And then you will 100% be ensured that none of your features going in the linear regression are collinear, right? You'll 100% fix that problem forever, right? But we don't do it all the time for the linear regression, because what happens is that your original variables were like, the alcohol content, ash, or color and stuff like that. Now, there is very little that you can define the PC. So how you can define the PC is basically the weightage of those, right? So for example, let's look into the first principal component. This is PC1. And these are what? These are the coefficients, or what we call in the more common language as the loadings of x's, right? So what are the loadings of x's? So for example, if I were to define what is it that principal one really captures, what is the essence of the principal component one? You look at what is the highest loading in this principal component. Yeah, so the highest loading is like this. So you can say it basically captures your dimension of magnesium and phenols. No, sorry, I'm looking at the wrong row. Phenols and flavonoids, right? So it's capturing the phenol and flavonoids underlying data much more in the principal component one. Similarly, what is being captured, let's say 2 highest loading over here. The next principal component, this is PC2. Similarly, this is PC3, PC4, and then PC5, right? So what is it that PC2 is capturing? It's capturing this first one, which is alcohol, right? Alcohol and then color intensity. So it's basically capturing the qualities of the wine, which is, how dark or how light the color is, and what is the alcohol content of the wine, right? So it's basically capturing those dimensions, and then you can see how the rest of the things are. And then last but not least, so when you started your, till now we haven't done anything. We haven't, like, we have just done over here, if you remember, when we did this, we just did the fitting over here, right? Yeah. May not be directly. Eigenvalues is capturing the true essence of the explaining power, but this is like, directionally. So it's like, directionally how much we can say one component is being able to capture in terms of, but it may not be adding up to 13 exactly. But the explain variance will be adding up to the 100%. Yeah. That's what I'm saying. So it will not be adding up because it's just directional view that you are getting from it, like how much is being captured, like at a rough level from the modeling point of view. But the explained variance will be much more accurate number for 100% explaining power. You can check the feature importance. Yeah. Okay, let's carry on then. So I think we were here. Yeah, so I was just highlighting that we only did the fitting till here. We didn't do anything else. Fitting only we did. So once we convince ourselves that the 5 components are the right components, so you can see this is my original X, and it has a shape of 178 rows and 13 columns. Everybody sees this point? Now, the same instance that we've created earlier on, this is the instance that we created earlier on. Now we are doing fit transform on my scaled X, fit transform. So when I do the fit transform, so I have already fitted a PCA with 5 components. So now it says, okay, I will take your 13 columns and transform them into 5 components, right? So the moment we do it, you can see now those 13 features are now shrunk to the 15 components. Sorry, so 13 are shrunk to 5 components now, right? And this is what? Any idea? This value. Yeah, this is the same thing we were talking about earlier, which is the alpha 1, x1, alpha 2, x2 till alpha 3, x3 is basically capturing all the information in that one. You get the idea? So for that row, what was the 13 features earlier on? It has taken that and it has said, okay, principal component 1 will be going with the loading of alpha 1, alpha 2, alpha 3, alpha 4, but it's digesting information of all 13 previous columns and it gives you one observation. Similarly, for this, it does the same thing and so on and so forth. So, and that's how basically you can see now instead of 178 and 13 columns, now we are looking at 178 rows and 5 columns. And you can take this and put that in a random forest or any sort of ensemble model. And I think you were bringing it up, Parpan, earlier on. This will be a lot faster for you to train as well, because you have just lowered the dimension of your data as well. The model may be able to learn a better behavior because there's no hodgepodge of things. It's clear that PC1, PC2, they're not related. It's much more clear signal the model is getting. So it may be that you are getting a better model as the output of that. Not a guaranteed thing, but you will definitely be saving the compute for running the model. You will be saving the time to run the model, and you may have a better performance of the model as well. Not a guaranteed thing, but you may have a better performance. But this is pakka, you'll get. Compute will be less, time will be less to train the model. Performance may be at par or better, or maybe even worse, depending on what we're trying to do. So that's what the PCA really boils down to, right? No, no, because it's like the entire thing that you're transforming. Go ahead. It is a model. It's a technique. Okay, so maybe not necessarily a model per se, but it's a technique. You're not doing any prediction. You're doing a transformation. That's right. There is no prediction. Yeah. It's a raw material for further processing in most of the cases. It could be the end product by itself when you want to really account for, certain other things like, other applications of the PCA. But most of the time in the typical machine learning workflow, you will take it as the feature engineering and not a model per se, not the end product by itself. You had a question as well? So in terms of the workflow, you will go through your missing values, outliers, right? What else? Dummy coding, all of that will be done. Then you'll be coming to your scaling. Then you'll be going to your PCA. Then you'll be going to your modeling workflow. Right. Yeah. Yeah. So if let's say you're looking at a linear regression model, this would be a good homework that you can try. So if you build a linear regression model with the components, can I see a higher R square? Can I see a higher a lower mean square error, right? So that would be a good thing for you to try out in the picture, right? Is that clear? So, yeah, please. Yeah, that's the part that we spoke about, and because that's a linear algebra. I don't think you guys have done linear algebra till now, right? You've done that. So you know the matrix computation, some of the matrix computation. So it does basically the flipping of the matrix and all the other things, right? Yes, exactly, exactly. So it'll ensure that, when I'm looking at this component coming in, because of the matrix computation which has gone in using that method, I'm not necessarily looking at overlap between this component and this component. So they're orthogonal, but not in the sense of 90 degrees. So it's just saying, when I do this matrix computation, we get this component coming out from there. I will flip it in a way that I get another component where there is very little or no, I mean, there's no overlap actually in that sense. Yeah. Okay, so let's park it here then, and then we will move on to the next topic, which is I think there's some network issue. What it's a little bit slow. Yeah, so we'll go on to the last topic before we take the lunch break. And I'm just trying to see what else is remaining. So there'll be two topics we can cover post lunch, which is the time series modeling. And there are three different time series modeling in there: Holt Winters, Arima, and then Prophet, right? And then we'll be covering the auto glue on post lunch. We'll be talking about this model explainability, last article. So if you can just take a look very quickly, article number 57, while I do the print and everything that I've been doing. So we'll discuss that before the lunch break. And are we doing 1 o'clock today, Abhi, or later on? One. Okay. This is very important for like pretty much all the different models that you're going to build on, which is the model explainability part, right? So I'm just going to save this article. And once you guys have done the reading, typed your code in, it's a copy paste code. Let me know. We can discuss quickly. Last article, very last article, model explainability. I just added this morning only. And your how many assignments you've done, Abhi, till now? Three we have done. So today, your last assignment will be your time series modeling, the one that we're going to discuss post lunch. You will need to replicate the entire thing and then submit that, right? So once we discuss, then you will know what exactly is there in the time series.
Please, I'm just happy.
Yeah, please.
Yeah, from Sweden office.
Hi, come, please.
Pandey is
Hi.
one of our favorite
Nice to meet you, Gopal.
Yesterday, how many of you attended the, oh, okay, big hands are, there are future, yeah, so we'll just sit and see what.
Please, yeah. They are just doing some reading now, then we'll start discussion on it. Yeah.
What is the last one?
Today is the last one, yeah. Hmm? Yeah, for the explainability. You guys have interest in any particular topics or?
Want to see how the classroom model, how people learn.
Yeah, yeah. Okay, okay.
We want to train people.
Mm-hmm.
Both.
Finishing school sort of, okay,
My background, I was in IBM 26 years.
okay.
Yeah, I joined a mid-sized company in the US.
Hmm.
Indian Technologies.
He's
we are-
a CTO of,
Okay.
He had a placement of.
Okay, okay, okay. Got it. Yep, absolutely.
Here you have been. Yes. Very active in LinkedIn.
The roster.
Want to share your thoughts?
Maybe share one of the most proud moment of your journey so far. Whatever you think you have accomplished as a big win.
Here, three class, two modules I did. Here actually, I have completed this third module, Python, statistics, and statistics machine learning. So Python, most of the basic things to whatever required for machine learning, to work on machine learning, we learned everything. Then statistics also we almost covers everything it is required to do machine learning, because to do machine learning we need statistics very much, because all of the machine learning models are statistical models. So statistics is required, and also like linear algebra we completed. In machine learning, there are many topics like gradient descent and all, which are very much uh, dependent on calculus, derivatives. So everything we covered in statistics and mathematics models. And another good thing is in machine learning, we have some models for linear regression, logistic regression, PCA, K-means, all these things in mathematics module, our last module, we did it pure mathematics. So no, there is no libraries and all. So first we have done, we have taken small data set, and based on the small data set, we solved that using pure mathematics, and whatever steps we have used in the mathematical way, same steps, we converted that to Python without library. So we know how, for example, we know how gradient descent works in and out. If you ask me to explain gradient descent in 1 hour, we all can explain in and out things. Linear algebra, how it works internally, what and all, what main algorithm behind that. So that also we have done in mathematics. So we know what actually libraries can, anyone can use library. So there is no issue with using libraries, but we should know the internal things. So we'll get more confidence. So current module is whatever sir told us to release. Module name is model explainability. So here also there are many things which we cannot interpret. It is a black box kind of things. But if there is only there is a topic called trust. So if we know how that model works, we can explain that model to others. So in many places, I heard from Sarah also that we need to explain if we write a model, a linear regression or logistic regression, we'll get accuracy and all these things. But we need to explain these things why we can use this model in front of statisticians. So if we know how it works in and out, if we know that all the performance metrics, how it works, what actually this performance metrics does, we can explain everything to them. So to explain that explaining purpose also, it will be useful if we know in and out all these things. Now machine learning, what we already know, many things in already learned many things from mathematically in machine learning in mathematics and linear algebra calculus models. Now when machine learning starts, it helped us to understand the things. That time we understood from the mathematical way. Now we are learning how we can do better using libraries, because libraries developed by Python, and there are many more things which we can do more easily. So if we use, if we want to use like implement gradient descent, if we want to use, if we want to implement our own linear regression, that is on machine learning module, we need to write lot of codes. We have one simple function called feed, and feed is if we use feed is to train the model. We need to pass the data set, what for which data we want to train the model. Inside feed, lot of things lot of things happens, like how the model trained. If when I train one model, it is not my machine learning model will not be like 100% accurate, 100% correct. So there will be some error. So how my model reduces the error? So it is an iterative process. There are some statistical process also and iterative process also. So all these things happen mathematically inside feed function. So now we did all these things mathematically using Python. Now in library, Eclipse library, we are having simple called feed. So code will be easier and easier to write the code. So after learning mathematics, we are using now libraries, understanding more in machine learning. So almost all machine learning topics, linear regression, logistic regression, decision tree, everything we have covered, market basket analysis, so everything we have covered, we are doing good. So,
Your height.
He hasn't shown his manual. He does everything by hand also. Huh? Like all the math by hand. So for example, how does the ensemble model really work? Yeah.
So, how many years of experience?
I mean,
Where you started with career?
I started my career as a call center and this training. Then while doing call center, I started learning software testing, manual testing from QSpider. From there, I joined one company called Rebusoft as a manual tester. And from there, I work. There I worked 1 year. I started learning automation. So after learning automation, I joined CenturyLink as an automation tester. And there in CenturyLink, one of my colleagues, senior colleague called Mary Zen, she is from US. She inspired me that upon you are writing the code, you have good technical knowledge. You come to development team. So I started learning Java, all these things. I switched to from automation to Java development. So from there I joined Capgemini. From Capgemini I joined Accenture. I was GraphQL SME there. Everything as a developer, Java developer. And now I'm working for HCL from past 3 years, from a couple of months. I am working as a GenAI engineer there.
Great.
Very good career history.
Mm-hmm.
That you're already making it on steroid, but what is that you are going fundamental.
Yeah,
Yeah, that is correct. That is correct. Yeah, yeah. That's very important.
Number one BPO in 2000, IBM acquired us. I'm not a software development guy, I was always managing the infrastructure.
I started my career from Pocha Infotech. That is what.
Great, great to know you. Door in our door is open.
You got the offer right away. What are you guys hiring for? Just for my information, what sort of roles you are?
See, here, give you a brief background of
Uh-huh.
our company.
Sure, yeah, please.
We are- This company has been in business for the last 24 years. Based on how the technology is evolving, our founder is a single man, entrepreneur.
Mm.
He built that company, they are currently $400 million company in the US. Now, recently you are acquired by another company called Digital.AI. And under the umbrella of Digital.AI, you have four companies. Vivian, then Genis.ai, platform-based company, Genis.ai.
Mm.
Then you have Access.com, analytics company.
Mhm.
Then Electroplast is cybersecurity company. All put together. Now, when you deploy AI, you need complete depth of all things, amalgamation to deliver a service to the client.
Yep.
They are solving a lot of business problem for big companies, where the big IT service companies are not able to solve. Not able to solve in the sense, big IT company, by the time they engage, by the time they deliver a POC, 3 months. We deliver a POC in 3 weeks. Okay, we do
Got
everything in
it. Got
3
it.
months.
And this is the conventional AI, Gen AI, or the Gen AI, everything?
Yeah.
Okay. So you're building the chatbots and the agentic workflows? Okay. That's a good field to be in. I mean, people really would, yeah. Yeah, yeah, yeah.
Yeah, also most of it.
Very interesting.
That's the reason this is our first time to see, we know
Uh-huh.
IBM people.
Yeah.
For delivering one project, my
Mhm.
over after that, I never interacted, I never came to campus. This is the first time I'm coming to campus.
A lot of these guys are scared that their job may not exist because of the AI. What are your views? Because there was one article that everybody is talking about on LinkedIn that, yeah. So they're saying, yes, computer science, yeah. Mm-hmm. That's right.
Then
That's right.
people keep telling jobs are not there, jobs are not there. The guys who are creative, always jobs are available. So I'm not very creative, but I
Yeah.
found my way out.
That's right.
I was focused on execution, any complex things they give.
That's right.
go
That's
ahead.
right. Yeah.
I can find the people who will execute on time.
Absolutely.
This is
Absolutely.
funny. This thing, right? All true. Anything people talk in a boardroom is not possible.
Mhm.
Just stand up, I will do it. That is an idiot, this guy is standing up and telling, more about subject matter.
It dies for acceleration.
Then it's like, what happens, I commit 2 days, I'll get done in 2 days, 2 weeks, I'll get done 2 weeks. Then everybody started thinking, we have so many management peers are sitting in the boardroom. This guy, with basic degree, he can do anything. It was always the gut helped me to go, any problem anybody throws, I'll solve it.
Yeah. That's great. That's great.
I could not
Yeah.
learn deep technical.
Yeah.
Strong
No, of course, yeah. Now you don't have to because of the AI. Now you don't need to learn the coding and all the things. AI can take care of all of that. Yeah, yeah. That's right. That's right. True.
But beyond the point, in the past 10 years, I've become generalist.
Hmm.
I could not feel the deep tech. Sometimes I feel, I changed my career for wrong reason. I would have been techie.
You need people at all levels, no?
So great, seeing you, knowing you, Arpan.
Anybody else who'd like to cover? Yeah. Anybody else would like to highlight what your learning has been in the module? Whatever you have learned, whatever you have found interesting. And again, we are still looking at the through the lenses of the module champion. End-to-end is covered. Okay. So you can go in one area then. Santosh, you want to take a step? Yeah. Santosh would like to cover. Oh, acha, Poonam is saying something. Yeah.
On thing. But yes, I've always like you went down that technical stuff. I was always a pretty fan. I had that as a first time. Now I'm learning a lot of things like Python and modeling and all. So it's great getting it with and here we are doing the projects also now with the learning. So that is an add-on which I do not kind of.
Yeah.
Nice knowing you.
Coming in from a non-tech background, you have been doing really well actually overall. Santosh, you were saying something?
Yeah, the main reason I came here was like my daughter was saying a lot of things about AI. Like once what happened, there was a document in Kannada and she said that I can convert it to English. I said, how can you do that just for me? And she did that actually. And but she's not technical. She went for MBBS. This is the first year for her. And she said, you learn AI in so much. And it's like if you look at it, like I have a background of data warehouse for 15 years. I was working for Dell, but currently I don't have a job. So the challenge was that coming from those on-prem application to AI-based and all, there are a lot of things you can see, but in the backend, what happens, the things are different. Like people can make it 5 minutes. There are young people like Harshit, they can be in 5 minutes, right? So the challenge for us was like we are slow learners. I mean, so it's okay to see what you can do. Then one day, what happened, there are a lot of posts which will confuse you basically. If you go to social media, or even LinkedIn,
So true.
like that, it's confusing, like they will give one diagram, explain, but nothing will help you. You sit down and do the whole method. So the interest came for me, like I thought, okay, let's give it right in this one. And when I came for 2 trial classes here. And I saw that there are something different here, which we are going to learn here. So I decided to join the course. And I did Python. I mean, I'm a Java guy. So basically, like Arpan said, right, my career started with a computer center called Apple. So I was a teacher for 1 year. I used to teach, I'll just take you for 5 minutes that graph. So my thing was that I wanted to become electrical engineer. I never liked computer science because nobody knows what is happening actually. In our college, like I am from REC, it was called REC earlier, Regional Engineering College, in Silchar, it's Assam. My dad was posted there. I wanted to come to REC Calicut, study electrical. Somehow I did not get. Then the challenge was that what to do now. So I got a civil engineering there and finally I decided to change the branch. I got into computers. Everybody in my college said that you're done now. You cannot pass this subject at all. I mean, seriously, then what happened? I came out of the college. Then the moment I came out, it was Windows 3.11, which is a DOS kernel. And so there was one of my friend opened a computer center called Aptech Computer in Guwahati, and he said, I need a faculty. And I said, I don't know what to do because I was working in English dummy terminal, the green prompt. Right? And it's called dummy because it doesn't have anything, no CPU, no memory. So I was teaching this one, people were asking questions. Then I completed 1 year. Somebody says, what are you doing here? Go to Bangalore. A lot of people who were the computer science came to Bangalore, and then I finally landed here. It was 1998. I came here and I was searching for a job, same thing again, we have to go through applicant days, a lot of people in the queue, 400 people in the queue. They say REC, IITs can say that can go.
But you are from the REC then.
Yeah, I was from REC. So
Yeah.
And most of the time,
Entry to the door.
yeah, and most of the time you don't go because this mechanical and electrical guys are very smart. They get into Infosys test and all, right? And we are like not studying. Secunda they will do, right? We never used to study that one. Then there was something called Boston Computer here. If you have heard about it, they were giving job like if you're a PE, they will give you a crash course. So there was an interview, and they said that if you can do Java in 22 days or something like that, we'll give it 7,000. I said, okay, fine, let's go and try. And I was selected there because I had a background of faculty aspect. So I was teaching in Boston for around 6 months. Then there was a company called BFL Software. I joined BFL Software. That was in 2000. And then my career started in software, and like I worked for BFL, then I went IT technology. That was one company. So I worked for product company, and my career, I never changed much. Like whenever I went to services company, I was not a nice guy because they had some UAT testing, SI testing, they fails and they blame you. So I was like product guy. When I joined Teradata and worked for 18 years there, and all the time there was something for me to do for customer. But things change now, so that's why I'm learning AI. Planning to do something like if I can design the application. And one of the interesting thing, we are learning machine learning here. So I was trying this AI 900 course because we have AI 102, right? And I'm not very good in certifications. Like I did Corba and all once upon a time, but it's like very difficult. So whatever we are learning here, they are actually using it there. The problem is not that, I mean, the problem is understanding those features. So
Yeah.
I'm not getting 100%, but at least 30 to 40%, I can relate why they're using the components.
Yeah,
And I'm planning to do the certification for solution architect also for AWS.
that'll be great.
And this is what I'm planning, but again, like it's not that easy. Because at this age, if you study more than 3 hours, difficult to mind when I got. Yeah.
You have to sleep for 4 hours.
Sorry for taking so much time, but
No, these are good stories that we like. We were not really, yeah. Yeah.
You're challenging, we have 3-year experience guys now, we have to start.
and if somebody is posting that no machine learning very agentic now, that.
Well, I mean, I think machine learning will be there, but do I really need to hire a data scientist for doing that? That's the question mark, right? I mean, up to a large extent, I mean, you will be working along with the AI for doing the AI work, not necessarily you have to do completely on your own. That's how the direction has been. So, I mean, a lot of companies are really forcing that you should be using AI like 70%, 80%, so that you are able to do the productivity gain. You are able to show that something that used to be taking 30 days is now taking 5 days for me to really do, right? So that's also a metric, but the concept, the intuition, the why we are doing certain things, if you get a code generated from the AI, not I mean, somebody in this class or some other class, right? I mean, so the simple linear regression, it generated such a complex code, right? That why would you have that, right? I mean, you can just have a simpler one where you can do A to B to C. So I think that's where, I mean, we have to really club the AI with our own knowledge, right? So it's not going to be AI or a human, it's going to be a combo. But yeah, I mean, do you have to build the model from the ground zero, everything on your own? Probably not.
Yeah, so there is one thing like, he's like, it's very motivating to see notes. Another thing was like, he always comes with a naturally. So I was like thinking that who has developed this Python library, they're really genius. But there are people like him who actually are very interesting. He was saying that, okay, I will solve it math. That also was very encouraging for me, although I'm not
That's right.
looking for all his notes, whatever he's done, but I'm able to understand at least at high levels, like the story point of view. I think you can show the notes, whatever he does, it's like leading. And then one more thing was like I said, social media, right?
Yeah.
It's very dangerous because one of my relative cracked this what is that called? UPS, right?
Uh,
He was not in the social media for 3 years. He was not there. He said that you don't need to go there. If you go there, you are done.
Last.
You're lost. All manual books he was referring. So, but it is very difficult for us. Like, we made so much use to it, WhatsApp, all these things, right? So at this age, people like me, learning will be very tough.
You need one more agent AI to learn social media. Yeah, everybody is mounting.
Age is just a number. That's a wrong
It
thing.
was not, it is not, if you is in the football match, right? You know. Yes, I tell you, I was, 2020, I climbed this Kedarnath, okay? I was very confident.
Sorry, when was it?
2023.
23. Okay.
That was my final Jyotirling.
Hmm.
So we could say that you cannot do it. Like, I mean, in my house, my wife and my these daughters are like in Libya.
Huh.
We party together.
Huh.
Cannot do it. Leave it. You are 80 kg. How you will climb? If you take the decision to climb, Shiva will. If you get in the top, no. Every step is the Shiva. Very difficult. I'm telling you. This course also, I'm telling you, today morning, my wife was saying that to me that we want to go today. I'm trying to be, I mean, I just want to go and study for some reason. It's like really motivating. So it is not like that in number. Still disagree with that.
In person to person, it differs. Completely differs.
There are physical limitations, I'm telling you. Okay, there are condition of your aging thing. You have to agree. Okay, there are very few people who can really be, 25 at age of 50. It's not that easy.
So, we discussed on this last time also. I told you that, let's not talk age, because I am almost similar. As you are, but again, almost similar. But see, it all depends on how you think.
Yeah, exactly.
If you think that age is gone, it's gone. Today, I am from the marketing background, okay? I'm learning this from my sheer own interest. It's not that something which is taking it, asking me to do it, or my job is going anywhere. It's not like that. But it's sheer interest because I know if I learn this, more I can apply this somewhere. I always ask question in terms of what is the practical application.
Yeah.
Tell me. Because unless
Calculate over your skills.
exactly. So that's how it is. That's the application.
But you have amazing mentors here, no? Dr. Simha, he is old, no way. No.
Yeah. He was the one whose class I attended, like, he gave one example of intelligence. I'll tell you, let me just tell that, very interesting. So I was in that corner and he was asking, what is intelligence? And everybody is like, what is intelligence? So he said that, okay, you define, but the definition what he gave was that, he said that intelligence is something which you do not have any previous experience, you don't have the data, and you can take a decision. For example, if I am posted to, let's say, China, and I'm an RB guy, I would take a decision, right? I don't know Chinese, first of all. So it's like something which if you already know, then you have the data, right? So you have the, like, you said, right, you have taken a lot of customer experience, right? My manager was like that. He used to say that, still there. He said that there are, 99 way people will say that this cannot be done. And he was always positive. And I was working with him for execution, like you said. We used to meet the deadlines, timeline, whatever happened. We come with a release notes and we come with a known issues. This is the way software works, right? You cannot be 100%. So we used to come with a release notes and this one, known issues. So what happens finally? Your release will be done with some exception. And
That's so true. That's the right mental model. Yeah. Yeah.
If you think all the problems will solve in this world and it will become one day, it will never happen.
Yeah.
And relate this with one example. I attended one skill conference in IIM Bangalore, run by global companies and outsourcing companies together. They said India is on top on skill. Within top 10. We are fifth or sixth. When it comes to talent, we are 63. You look at what you said exactly, it is between skill and talent. The intelligence, the kind of education we have come.
Yeah.
So,
Yeah.
we can solve any problem. We can write a code. You give it the right code. But if you get into a global competition, you want to stay ahead of them, you can't, because you don't apply the rest of your trials. That's where the problem is. And it was surprising, how come you are 6 years, 63 there?
Hmm.
Maybe it's not great this couple of years before, 7, 8 years before.
Yeah.
This is through a proper study.
So learning here is like all mathematics, mathematically we are solving it. There is a reason whatever we are doing it. Yeah, of course, like for me, it's taking a little slower, but I'm just trying hard. So I think at the end of this course, definitely we'll have very good foundation about how things are working. Right now, whatever I have learned, I had asked question very simple one, right?
Sure.
Like, so.
Great knowing you all, and I think the right diverse team, that is also important, is the right.
It is very important, yeah, for the learning of the broader class. Yeah.
Here, how keep that with the mathematics. We are hearing some linear algebra statistics.
Mm-hmm.
So, is that how essential, how deep is really required for?
It depends on, what you, and I think this is the $1,000,000 question, how deep you really want to go in the math and the algebra and the statistics and everything, right? So, in my view, this is, just my personal view. You have to be thinking about what is going to be the career path that you're looking at, right? So if you want to be in the research, if you want to go for the PhD, if you want to really challenge the algorithms, how they are thinking right now, you want to come out with a better algorithm. You must deep dive into everything and how, like, one of the library in sklearn, for example, is working, right? However, if you look at from the corporate point of view, like the implementation point of view, we really don't emphasize on that dimension that much, right? We really say, okay, if you know that there are 5 techniques out there, you have to build the best possible model for solving a business problem, right? You will be gauged on how well you have solved that problem and what is the dollar impact coming out. So there is a research which will ultimately lead into a dollar impact. But from the corporate point of view, when the people are coming from the hiring and all of that, I mean, of course, depending on the teams that you're going to be part of, the focus is very heavily on the implementation. And can you think like a business person, a product leader, not necessarily a data scientist, right? I think that's what you guys will be doing in your finishing school as well. We really don't need people who just talk about the statistics all day long, right? We want the business application of that. And that's where the rubber meets the road, actually. Exactly. Yeah. Yeah. That's right.
We are not like foundational learning to application.
Exactly. Yeah.
Actually, I heard from my team, my colleagues, from Lean team, many places. India is a consuming market. India only, India only, like, they want to adopt AI, all those things. I want to go different direction.
That's a great
I
idea.
want my, I want to build something by my own. When I will be not there, my algorithm will be read by someone else.
Wow.
Earlier, my career plan, initially used to sign a contract for 7 years, which means technology is not changing for 7 years. Even changing clients are within after 3. Then it becomes 5 years, then become 3 years, then become 6 months. Now technology is changing every day. When you wake up next day, somebody writes what you think also.
Yeah. Yeah.
Then you have to recalibrate yourself what I can write, something else different. Yeah, that's the level we are in.
But
And there is still unique space, as you said, there is unique space to do.
But I think grounds will be, the fundamentals will be same.
Yeah,
So for any technology, like Java, for example, I can give example for Java. So long back in whatever project I am working in, since it's they're still using servlet JSP. So that is the beginning of Java, they develop. Now, Spring Boot, on top of that, Spring Boot, whatever new Java framework, all based on core Java sublet only. So it will be changing.
exactly.
Fundamentals will be same. So for machine learning also maybe new.
The education fundamentals will not change now, or it will be.
Yeah.
Concepts, it's not different.
Yes.
Concept itself, to change it will be a lot of time.
Yes.
Okay.
Great. Yeah. I think we can break for lunch also, right? Yeah. Let's break for lunch also, since we're already. Yep.